Hello everyone and welcome back to another episode on complete reference to CUDA programming. So far we have discussed about what is GPU and its architecture. Now that we appreciate the computing power of GPU, so let's start actual writing a program that can be executed on GPU side. So for execution of the CUDA programs, I'll be using NVIDIA's cloud instance, which is having a Tesla T4 GPU. So in your case, you can install CUDA toolkit in your local system. There are plenty of resources available that demonstrate how to install CUDA toolkit in your local system. You can use Windows operating system or Linux operating system. It's your choice, but I would recommend to follow the Linux operating system. Now, once you installed CUDA toolkit, you can check whether it is installed properly or not using this command in your terminal, NVIDIA and -SMI. This will show the details about the GPU, the driver version you are using, the CUDA version that you have installed, and which GPU you are using. All these details will be mentioned. In my case, I have the cloud instance provided by NVIDIA, which contains Tesla T4 GPU, which is having a driver version here with the 460.32 and CUDA toolkit version is 11.2 here. This GPU is having 16 GB of memory that is mentioned here, and in this section it will mention percentage utilization of your GPU. As of now, I'm not executing any program on the GPU, that's why it is mentioned here 0%. So this is the GPU I'll be referring to execute my CUDA programs. Now let's talk about our first CUDA program. So for writing CUDA program, I'll be following C programming syntax. If you're familiar with C++, you can also follow that C++ syntax. Now we know that whenever we write a C program, we start with extension. We create a file and we give extension as C.C. In case of CPP, we give extension as .cpp. Now here we are writing a CUDA program, so extension of this file will be .cu. So this is my file 01 hello -gpu.cu, that is indicate it is a CUDA program. Now let's create this file first, and now I'll write a simple program that is going to call two functions. One is hello CPU and other is hello GPU. Here simply we try to understand the syntactically how to write a function that to be executed on GPU. So I'll first write main function here, and inside main function I'm calling two functions, hello CPU and hello GPU. So first let's understand what is this hello CPU is doing. If I see the definition of this hello CPU, its return type is void and it is not even accepting any arguments, and it is simply printing a message hello from the CPU and it gets terminated. So this is the definition of hello CPU. Now if you see this, we have another definition hello GPU with some crazy stuff here that is mentioned in the triple angular brackets. As of now, we'll skip this part because we have dedicated sessions on explaining these topics. Now here I am calling this hello GPU function, and let's see the definition of hello GPU. It looks almost similar to your CPU function definition hello CPU. Only thing added here is a keyword that is __global__. So this keyword tells compiler that this function is supposed to be executed on GPU or supposed to be executed by GPU. So by this keyword, I am telling compiler that whatever routine, whatever statements I am making in this particular function, that is supposed to be executed on GPU. So this is the way to tell compiler this function is supposed to be executed on GPU. Now what this function is doing, it is simply printing another message hello from the GPU. Now this function call is terminated here. Next we are having this CUDA device synchronize. Right, we'll see the purpose of this CUDA device synchronize in a while, but before that let's try to understand how we are going to compile this function. To compile this CUDA program will be using NVCC compiler, NVIDIA C compiler. And here a compiler flag will be mentioned on which architecture you want to execute. Then we'll pass this program name hello CPU or hello GPU.cu. Now you can see here we have two different names here. It is by mistake. I'll mention here that same name, that is 01 hyphen hello hyphen GPU.c, that is the program name. So this is how we are going to compile. Just like your normal C program, we use GCC compiler, we provide some compiler flags and followed by we mention the program name. Once I compile this program, then output file will be generated, that is a.out, and to execute that file we use /a.out syntax. So this is just like your normal C program compilation and execution. So these are the steps you have to follow. On NVIDIA GPU cloud instance, I'll be following different syntax. It is slightly different. So I'll be using NVCC compiler, and here I'm using architecture SM_70. And here in this case, I'm creating output file with the name hello GPU, and this is the path for that file. And after creating this hello GPU, I'll be using -run to execute that program. So here the steps are mentioned explicitly for compilation and execution. Here I am using a single statement which gives me compilation as well as creating that executable file, and after creating that executable file it will run. Now here we have this particular program. First I will execute without this CUDA device synchronize. Now ideally what we want these two statements to be printed, hello from the CPU and hello from the GPU. So let's say what happens. I'll execute this. It will give hello from the CPU. Now if you see, we are executing two functions. One is executed on GPU and other is executed on CPU, but out of which only the function which is printing hello from CPU gets executed, that is from CPU side, and this function is not printing any output. The reason is, as I mentioned, we have two processors here, CPU and GPU, and its control is toward the CPU. So when it start executing main function, the control is toward the CPU. Now CPU goes to the next step and it will execute this statement hello CPU. It will print hello from the CPU. Next statement we have hello from the GPU. CPU launch this function, but this function is supposed to be executed on GPU. Now when this function gets called, this function start executing on GPU side, but before this function start executing, CPU is not going to wait till this function completes. CPU directly go to the next statement to be executed, and next statement is return 0. That means termination of your main program itself. By that time, this hello GPU start printing the message hello from the GPU, your program gets terminated, and that's the reason we are not able to see the output from the second function, that is hello GPU. Now if I put some restriction on CPU that you have to wait till this function completes its execution. That means till this function complete its execution on GPU side, CPU must wait, or CPU cannot execute the next statement, and that we can ensure by using this statement CUDA device synchronize. So now CPU execute this hello CPU, then it calls hello GPU, and before it goes on execute the next statement, that is return 0, CPU waits till this hello GPU function is executed by GPU, and once it is finished, then it goes on executing the next statement, that is return 0. And now if I go back and try to execute this program, you can see here hello from CPU and hello also from GPU gets executed. Fine. So that's it about this simple hello program on GPU. So key takeaway from this is we are going to use global keyword in front of a GPU function to tell compiler that this function is supposed to be executed on GPU. We will use CUDA device synchronize to synchronize CPU and GPU to restrict CPU from executing next statement before this function GPU function gets terminated. Now we have seen how to compile a program using NVCC compiler and how to execute using a.out.